Good morning, everyone. Hi, my name is Paruch. I am from Vienna, and I came here today just for the workshop about prediction markets. By trade, I'm a mathematician and economist. I work at the University of Economics in Vienna. I have my own company, Token Engineering Labs, where we, since almost 10 years now, design protocols, design token systems, design incentives. The focus of my work, based on my education, but also my interest, has evolved around market design, has evolved around designing protocols that relate on to functionalities on the application layer, and mostly relevant, everything that has to do with information aggregation, everything that has to do with exchange mechanisms, everything that has to do with price discovery. And this brings us into the story or into the narrative of prediction markets, because there's an advent in crypto, in Web3 right now, where prediction markets have gained quite a bit of traction. So what I want to talk you through over the next 50, 60 minutes or so is what prediction markets actually are, how they are designed, what are the building blocks of prediction markets, what happens under the hood, and how you can build applications on top of it. So we want to cover the full spectrum from mathematics, economics, over token standards, smart contracts representing the individual functionalities and the assets. And then we want to talk about implementation effects. And some attention we will put towards market microstructure and market efficiency. So we want to look how you could design prediction markets, how you can build them, which mechanisms exist that you can use, and how this choice that you make on the microstructure side will result in different outcomes or trade-offs on the trading or the performance level. So this is an academically grounded talk. We want to base our conversation in academic literature, in state-of-the-art economics, but we want to be very practical. So I want to show you how you can actually talk through a full process where at the end you would eventually be able to say, hey, this is how you can design and build a prediction market. I assume that most of you here in this room are familiar with prediction markets. This is what you see here on the right-hand side. This is a chart that is from Polymarket, one of the biggest prediction markets out there. And this is representing two price paths of the election in 2024, I believe it was, between where Trump was elected president of the US. So what you see here is a price development of two assets, and you see that over time and by the end of the poll, when the election actually happened, so November 8th, you see this price convergence towards one of the outcomes. And this is what most people associate prediction markets with. So they think of it as prediction systems, they think of it as betting systems, maybe to some extent even gambling, because you can indeed place bets and participate in those systems. And then eventually, when you are right, or you can even make profit out of it. But the narrative today, and kind of like my selling point, is that I want to say that the prediction markets are actually far, far, far more than that. So they are not simple betting systems. They are actually information aggregation mechanisms where each interaction by users or by traders is a signal that comes into the market. And then there are specific market functions that take in this signal and transform it into some aggregate metric, which is, in this case, the price, that can be interpreted as the probability of the event. So for you to remember one thing, we are creating assets, or we are creating markets where the goal is to bet on future events, on events that are unsure yet, uncertain. And we want to use those price paths of those assets that are being traded as estimates of the probabilities of those events happening. And I want to show you how the different choice and the different design of those markets will allow you a completely different interpretation of what this probability actually mean, and how you have to be very careful about how you design the market, because you can get completely different results or completely different probabilities as an outcome. Prediction markets are designed to facilitate information aggregation. So this is the goal. We actually want to create a marketplace where the goal is to aggregate this information and spit out an aggregate metric. But what we also want to do, and this is key because this is the only reason why those markets have credibility, is we want to incentivize truthful reporting, which means that we want to design a system where everyone who participates provides their true estimate, their true probability estimate of the event, rather than just participating with some random input. Because only then the information that we receive is valuable, because only then we can aggregate it, and only then this aggregated metric is also very valuable, because we then can say, hey, if actually everyone reported honestly, then the aggregate signal is also honest, and therefore we can actually use this price that is can be interpreted as a probability. But what you see here is already the first hint at how an economist or an engineer would approach this problem. Because what you would typically do is you would define some requirements, and then you would try to derive from first principle a mechanism or a set of mechanisms that actually fulfills those properties and allows you to have a system that keeps those properties intact and achieves what it is designed to do. So the goal of the workshop today is along this spectrum. So we want to understand what prediction markets are and what is being traded. What are the assets that are actually priced there, and how do you create them, and how do you represent them on chain? We want to define and compare core market microstructures, because I can immediately tell you that there are multiple ways how you can design such a price aggregation mechanism. There is not only one economic mechanism that achieves that. There is a multitude of mechanisms that you can use. We therefore want to evaluate those different mechanisms under different regimes. So we want to look at their performance. We want to see how the different mechanisms behave given particular signal inputs, and what this means for us as market operators, market designers, and traders. We want to look at it also from the implementation perspective. So we want to look at it through the lens of a developer and say, how can we, once we have this idealized whiteboard solution that we know how it behaves and that we find attractive, how can we actually implement it, and how can we actually build such a system that achieves what we're looking for? And while we are doing all of this, I'm going also to sneak in a little bit of the engineering workflow so that you also have a structured process at hand that you can use for your future design projects, where you can say, hey, I remember this is what we did at the workshop. If I follow those steps, I would actually achieve something. I would end up with a mechanism that has nice properties that I'm looking for. So first, let's take one step back. And this might be quite surprising, because we are not going to talk about prediction markets at all in the first two slides. What we're going to do is we're going to say, hold back. Sometimes prediction markets are not the right mechanism for you to use. So there is a whole family of different markets, of different mechanisms that a menu of mechanisms that you can pull out, and you can say, I want to build something, or I want to use something, and I want to achieve this, but maybe what is the best mechanism for my choice? And this is interesting because right now prediction markets are booming, and I want to emphasize in those first two slides that maybe some of the projects or some people building those things choose a system or choose a mechanism that is not tailored to the purpose that it is used for. And we want to anchor this in a paper by Kameda et al., which is published in Nature in 2022, where the authors basically review consensus-making and combined decision-making mechanisms in human and in animals. And what they say there is that depending on the information distribution across the whole population, meaning, is it only one person who knows everything and participates in a mechanism? or is information equally distributed among group members? And also, dependent on the dimension, whether we are defining a consensus decision-making or a combined decision-making mechanism, we have a full menu of different algorithms and mechanisms that we can choose and that will drive our market design. In consensus decision-making mechanisms, the goal is to make a decision together. So there has to be consensus. The group can only move forward if everyone agrees that this is what they want. This is the left kind of mechanisms that you have here. And the simplest one, if information is equally distributed, would be the unanimity rule, which means that everyone has to agree that this is the choice that they want to make. And this choice has to be equal for everyone. And then and only then the group agrees that this is what they want to do. It is a very slow mechanism. So there are trade-offs between efficiency and speed of those mechanisms, because you can imagine that this takes quite long for a huge population to arrive at one decision when everyone has to agree. While at the other hand, when you have the complete contrary mechanism where you say you have despotism or leadership, so you basically select one person from the group and say the group does what this one person says to do. And this might be useful if information is completely skewed towards this one person. So like if he's the only expert, if only he knows what is the right thing to do, then it makes sense to select this mechanism, right? On the other hand, if everyone knows the same, take unanimity. In combined decision-making, consensus is not a requirement. So individuals also take individual decisions. The group arrives at some decision, but they don't have to agree. So it can be something like random copying. So like you do whatever your neighbor is doing, and then everyone is doing this for some time, and then eventually the group arrives at one destination, and then this is what they have just managed to achieve. And again, there is a distinction between how is information distributed. So now, if you zoom in only on the left-hand side, on the consensus decision-making mechanism, you see again a set of different methods that are examples of such mechanisms. And now finally we see that prediction markets are one of them. So this is why I'm bringing this slide in. What I'm saying here is, only if you want to make consensus-based decision-making as a group, and only if there is some prerequisites are met, then prediction markets are the right choice for you to implement. Okay, so now let's look at it. So assume we have decided that we want to build prediction markets. Who of you has seen already kind of like how they operate, or more technically, what happens under the hood? The most common distinction is between information markets and scoring rules. And then in 2003, Robin Hanson came along, who defined market scoring rules, which sit in between those two of them. And we want to emphasize why this definition almost 23 years ago was so revolutionary and so important, and which important gap it closed. So imagine we want here as a group of 5, 6, 7 people, make a prediction about the future. We can create an information market. What does it mean? It means that we create assets. For example, will the football club in which stadium we are today win the next match? Yes or no? This is the question. This is what we want to predict. And what we can do now is we can create an information market. So we can now say everyone who is here can buy or sell opinions in this market. The problem that you have is that for such a small group as we have here, 5, 6 people, you will probably not find a counterparty for your trade. So maybe someone is willing to sell, maybe someone is willing to buy, but at completely different prices, which means that the information density or the trading volume is very, very low, which is what you see in this graph. So you see that simple information markets, they perform extremely poorly here on this side of the spectrum. This side of the spectrum is you have a high number of estimates per trader, which means that you have not many traders in the market. So simple information markets where you can exchange those opinions and we can trade those opinions, they work extremely poorly in a situation where there is not high volume, where there are not many people participating. So this doesn't work. This is inefficient. It would be cool, but it's inefficient. What are scoring rules, on the other hand? Scoring rules are an instrument or a mechanism from economics that has been used since the 1950s, where you can basically score participants individually. So you don't need to find a counterparty. I would do something different in this case. I would ask you all individually about your prediction of the future event. And I would ask you, you. You would report the probability distribution. So you would say, what do you believe will happen, or how likely do you believe something will happen? Then we would wait for the event to realize. And then I would score you, hence scoring rules, based on the accuracy of your prediction. So if you were correct, if your prediction was good, you would receive more points or more rewards. If your prediction was poor, if it was inaccurate, you would receive less rewards. Those are scoring rules. And you see immediately that for this to work, you don't need high volume, you don't need many participants. You can score everyone individually, so it works even with one person, right? The problem is, and you see this here, you actually don't get pooled opinion. So it's difficult to aggregate all individual opinions into one market belief. So I am able to score you individually. I know exactly what you predict the event probability to be, but I'm not certain, and I cannot aggregate this into a market probability. So I cannot actually say the market believes that the game will end in a win 60%. This is not possible. So we get to the opinion pooling problem for scoring rules, and we get to the thin market problem for simple information markets. And those are common and old historic mechanisms that have been used and can be used for this information aggregation to work. But in order to close the gap, 2003, Hansen introduced market scoring rules, which are basically the best of both worlds. So what happens there is, I also have a scoring rule, but this scoring rule is true for everyone. So there is only one scoring rule, and every one of you can interact with this one single scoring rule. And if you don't believe that the scoring rule is set correctly, you can change it, but you can change it at a particular cost. So you have to pay a price to move the market belief to a different point of the curve. What market scoring rules achieve are, if you have only one participant, so in the thin market case, they collapse the scoring rules because they are scoring rules, so like it's the same thing. But for high volume, if you have many participants, they become information markets, commonly known as automated market makers. So this is how where AMM comes from, where you have those scoring rules and you just kind of like have high market volume. So now you already see that by those different underlying logical algorithms that you can use to make a market prediction or to pool opinion from people, right? You get to completely different market microstructures, because in this case, you get to an information market, which is an order book style trading mechanism. And in this case, you get to automated market maker, a bonding curve style mechanism. And the goal of our session is to compare those two and see when does which make sense, what does it mean, what are the consequences, how do systems perform, how do you actually select one of those if you want to build a prediction market based on which criteria do you select actually want? So like how do you prioritize in a selection? And please remember, we are using those mechanisms because at the very first slide, we had those two requirements where we said we want to facilitate information aggregation. Those achieve that. And we want people to report truthfully. Those achieve that as well. Because scoring rules, and in particular proper scoring rules, which are a subclass of scoring rules, have this incentive compatibility property. So the rewards are maximized for participants if they report truthfully. So for every participant, it makes sense to say, okay, if I really tell you what I really believe, I will maximize my potential reward. So you already get a mechanism that elicits truthful information. You want this, check. And the other is information pooling. You can pool those signals into one common market belief. Perfect. This is what we wanted. Okay? So now you see, again, family of mechanisms, selection based on requirements, and ticking off all of those requirements to say, okay, we are on the right path. What are then claims? So which assets are we actually trading? How do we represent our beliefs? And what are the things that we are actually interested in finding the price? Some of you might have already heard of Arrow de Bro securities, which are exactly the assets that we are trading on prediction markets. They are specific synthesized assets that pay out 1 if the event occurs and pay out 0 otherwise. And the interesting thing about the prediction market here is that it's kind of like a reverted logic of designing, because typically you design a marketplace to facilitate an exchange of an asset. So you might have a commodity, you might have an asset that you want to trade, and you want to build a marketplace to facilitate exchange, right? This is the purpose of the market. Here, we're turning the tables because we're saying, we don't care about those assets. Those are synthesized assets. They just kind of like, we define them like that. But the purpose of the market is to aggregate information and to reveal information, to give us some metric that we didn't know before, because we create a market, we create those assets, and by allowing people to trade on them, we will find their true opinions because we will elicit truthful information, and we will pool those information into one common signal, which is the market price, which can be interpreted as the market probability of the event realizing. Perfect. So please remember this. This is quite important. We want to find a venue for the exchange and pricing of those assets, right? And you see here that those assets can be multidimensional. So typically, or intuitively, you would be thinking about two-dimensional binary assets. So for example, a yes or no question. Will Trump win the election? Yes, no. And then you can say, yes, if he wins, you receive $1, and no, he loses, you receive $0, so you lose. And this asset is being traded between 0 and 1, and it always pays out either 0 or 1 at resolution. So you can immediately see that the price at which it's traded is the market belief of the event happening. What you can do, just a mental note, because this will become important, you can always mint a full set of those claims by providing 1 unit of collateral, which means if it pays out 1, I can always say, I am giving this contract $1, and I create 1 yes and 1 no share, because those events are exclusive and exhaustive, so they cover the full event space, and then know that exactly one of them will happen, so I can actually make this primary market mechanism of collateralizing my contract and creating a full set of shares. All of the events outcomes can be represented, because I know exactly that in aggregate they are worth exactly 1. Perfect. So again, for a binary event, I think we talked this through already. We have a yes and no, pays 1 if the event occurs, pays 1 if the event doesn't occur. And then it would be very convenient if we want to build it. So like now let's talk about building it. for the first time, it would be very convenient to think about as fungible ERC20 tokens, yes? Because this is what we want, right? Like we have a yes and no, like they're all the same, so we can just create a marketplace. And then we can say, perfect, I know that like if we trade them separately, I know that P of yes, price of yes and price of no will be exactly one. So like I will even, if I create marketplaces for them, I know that like the people will come in and arbitrage the differences out, and you will have this this parity here. It's very convenient. So it's very nice to say, hey, let's build it, let's implement it. Maybe let's design a prediction market where we represent yes and no by ERC20s, and then we just like can start trading, and then we will have everything that we want. And it works. It's fine. But it has some limitations. So we will see what the limitations are. Once you have defined those assets, once you have represented them as ERC20s, you now have to think about primary markets and secondary market. Primary market, we talked already. We said that we can mint a full set of shares at any time by collateralizing one unit by bonding 1 unit of collateral. So like this is perfectly feasible. And the secondary market is now our choice. How do we design this, right? We are the market designer, we are the market operator, so we can choose which secondary market mechanism we want. We can make one marketplace for yes, and then we know that no will be exactly dictated by this. We can make 2 marketplaces separately, and then we will have arbitrageurs ensuring price adjustment. Or we can even create both assets and just pool them together in a bonding curve and let the market find the equilibrium or the market price. This is all our choice. We can do all of this. So this is perfectly fine. Now we are entering the design space and how we want to treat this economically. But the key distinction that I want to make at this stage is that we have something that we say is the claim representation and settlement layer. So those ERC20s that we talked about, like what is the Arrow-Debreu security representation? How do we represent it technically? What is it that represents the claim, and how do we settle it? How do we get our rewards after resolution? And we have on top of the claim and settlement layer, we have the market layer where actually those assets can be traded and price discovery can take place. And now we have to think about both of those things separately. So what is the best way to represent those assets? And what is the best way to find, to discover prices of those assets? And so far, we haven't gotten really far, but we have agreed on ERC20 is fine for the representation, and for trading, we can do any of those, right? Okay, but things can get tricky quickly. They can get tricky quickly because we are not bound to have a binary market. So like we can have more sophisticated event spaces. So we can have n mutually exclusive and exhaustive outcomes. For example, you have 10 candidates, right? And you can say which candidate will win the election. Or you have something like 100 percentage points. And the question is, how many percent will the winner of the election get, right? And then you can ask any number between 0 and 100. 0 probably not, but any number is an eligible number to be bet on. Which means that now you are segregating or partitioning the market, the outcome space into more outcomes, and all of those other properties still hold. So like you now have to have multiple n shares to represent those outcomes. All of them have those properties, have this yes payout 1 and 0 in case the event occurs or not. The prices of those add up to 1. So like all of those properties that we had with 2 assets still hold, and we can design those binary, categorical, range-based, or even continuous markets. Like we can get even very, very sophisticated by not betting on discrete outcomes, but on continuous outcomes or on parameters of continuous distribution functions. But the problem is this. Does it work with 1 ERC20 per outcome design? So was our intuition right? Can we use this? The answer is probably not, because it grows in size pretty quickly. So if we have this event space, we have so many outcomes, then the size of the space gets huge, pretty large, and then we would have to have so many assets so many claims, so many bilateral exchanges between them, so many arbitrageurs, so much complexity coming in. It just doesn't pay off. It's not worth it, and it's extremely operationally inefficient. So this is why we have a new question. We have a new goal. Now we have to seek a system where we can have one collateral backing many claims. Many claim types can coexist in one contract and not one contract per claim. Claims can be split and recombined. So like we want to have this efficiency and this settlement in the representation already. And we even can represent joint and conditional outcomes. So we can bet on things. I want to bet on B only if A happens. So more combinational event spaces. And this is where the conditional token framework comes in. And some of you might have heard of it. It's something that Gnosis introduced in 2017, 2018. Where they said, yeah, we want to have a token standard that exactly achieves all of this without getting too deep into the ERC20 one token per contract logic. So what does it mean? ERC 1155, we started here at the ERC20 level. We had one contract per fungible asset, but now we extended it to an ERC 721 where we have one contract for multiple NFTs. It's still not the thing that we're looking for because we want to have one contract for multiple fungible tokens, and we want to represent all of those claims within one contract, and we want to represent it as IDs within the ERC 1155 and allow for all of the claims and all of the combinations of claims and all of the complexity that is inherent to those markets to be represented by one contract and the pricing happening in this contract. So this is a very convenient standard, and most of the prediction markets that are built today leverage this standard. So Polar market is built on CFT. All of the currently, this is where kind of like state-of-the-art claim representation. And remember, we made a distinction between how do you represent claims and how do you do price discovery. So it would be interesting to see if we can actually trade those assets and how can we find prices for those assets. And the answer is yes. Gnosis even came out not only with the framework, but also they provided two prototype implementations, one for an AMM and one for a market scoring rule, such that there is kind of like an out-of-the-box contract and algorithm available where you can, using this standard, already build price discovery on top of it. But let's go back one step. Let's think about what a CFD is. It encodes exactly what we want to encode because it has those primitives. It has the condition, so the question that we're asking, and we define who is responsible for resolving this question or who is responsible for providing eventually the answer to this question. We have outcome slots, so how many different outcomes exist and what they are. We can define subset of outcomes, so we can make conditional or outcomes, or we can say we want to bet on A and B. So kind of like exclude only one option, but like bet on so Trump is not going to win, but someone else is going to win, all of the other candidates. We have the position, the collateral, we have the token ID, which represents the claim, and we define the payout vector that tells the contract in which proportion assets have to be paid out once the resolution is known. So very convenient standard, you can use it and you can build on top of it. When you think now about the life cycle of a position in this standard, what you would be doing is, again, distinguishing between the settlement layer and the market layer. So first you would define the position on the settlement layer. You would say who is the oracle, what is the question, what are the outcome slots. Then you define the collateral for the position. You can provide collateral and split, as we mentioned, into a full set of outcomes, because this you can do always at any time. So for an end token market, you provide 1 unit of collateral and you provide a full vector of outcome shares. And then once you have those assets represented on the representation layer, you can now enter the marketplace. And now we can say, let's find prices. Let's allow users to agree on the probabilities by mutual exchange. So this is what happens next. This is where the marketplaces come in, and then you can again once this is found, you can go back to the CTF layer, merge those claims, distribute, and so on and so on. You resolve the question when the outcome is known, and then eventually users who hold claims can redeem collateral by claiming and burning those claims. So this is how the position now works, and you can go. You can use it to realize a full market cycle on the settlement and market layer. Economically, you distinguish between collateral positions and redeemed payout. So first, you enter the market with 100 USDC. This is what you have. You provide 100 USDC. You create positions by minting a full set of shares. And then once the outcome is known, one of them becomes worth and the other becomes worthless, exactly the collateral that is behind it. So this is the economic life cycle of a position. Okay, so now that we know what claims are, how they can be represented, what the life cycle is, now let's step up again and let's talk on the market layer. What I'm showing here is a three-dimensional bonding curve, where you would be able to trade those assets on the current prices that are represented by the green and blue arrow in those directions by moving the inventory of the AMM from this point to any other point, and by moving remaining on this cost function. This provides always liquidity and allows you to basically have this liquid market and facilitate exchange. So you don't need a counterparty. But this is just an example of saying, okay, this is the automated market maker, right? But as mentioned before, we can also already talk about continuous double auctions, which are the ones that you would do on an information market where you would have an order book based. How do you define prices? Prices mathematically are defined by the directional derivative in the direction of one outcome. So, as you have seen on the previous slide, the small arrows are the prices, and you get those directions by taking this derivative. So the price of the asset E momentarily is by looking at the cost function and deriving in one direction and asking how much would it cost you to move the curve 1 unit in this direction. The full vector of prices is nabla C, so all of the directions, and then you get to those P1, P2, Pn, and we already know that they will add up to 1. So this is what we're looking for, right? So you can derive them individually by taking derivatives on the curve, but you can also check that if you do this, eventually they will add up to 1. This is how you would do it on an AMM. How would you do it on an order book? Multiple price definitions exist. So a very intuitive is obviously saying the last clearing price. So obviously the market price is the last price that cleared. So like if you found someone to trade, this is what the current probability is. But if you maybe don't have anyone to trade, or like you want to be more formal, then you can say, we can define the mid price as the market price. You just collect those orders in the order book and say, what is the middle between the highest sell order and the lowest sell order and the highest buy order, and then you can say this is the market price. But this can be completely imaginative, right? Because if I want to sell at 20 and you want to buy at 80, probably the other way around. I want to sell at 80, you want to buy at 20. It's unfair to say that the market price is 50, right? Like no one is agreeing on this price, but this definition would tell so, right? So you can approximate it. You can say, okay, there is this definition of a market price, but maybe this is not an actual market price. And especially you see the problem when we talk about this low volume or low liquidity situation where only us two exist. It's actually not possible to say what the current market price would be, right? There is one sell order, one buy order, one midpoint, but like, is this really the probability of the event right now? I don't know. Here you have always instantaneous prices. You are always able to trade. So like here you actually can find a price. So this looks very attractive in a low volume, low liquidity scenario. And this we have to see, right? What it means. We know that those prices add up to 1. We know that you can normalize them, and then you have this probability definition. This is just a formal way of saying what we already know, so we don't have to look into this too much. Perfect. So now we know kind of like the primitives that you would use to design a market. We know, so bonding curves or like market scoring rules and information markets. We've talked about the representation of assets, arrow the bro securities. We talked about a token standard that is helpful in implementing them, the conditional token framework. And we talked also about definitions of market venues, so how you could actually define prices, how you can derive prices, how you can facilitate information aggregation or price discovery, given that you have this situation. So now let's talk about what is the minimal implementation of a prediction market. So like, what do we actually need out of kind of like those elements that we've introduced to build our marketplace? And let's start maybe from here, because this is what we already know. So we have the substrate for event contingent claims, some implementation, some representation on chain of those claims, of those assets. Voila, you can use the conditional token framework. We haven't talked about this at all because the presentation doesn't have enough time to discuss this in more depth, but somewhere in between, you also need an oracle. So you need someone who is responsible for the resolution of those markets. So not only providing price discovery, but actually injecting the true outcome or the true realized event outcome into the contract, such that the contract knows how much to pay out to whom. Because this is all encoded, but it needs the flag. It needs to know what was actually realized, what is the outcome, and then it can derive all of the payout rules and all of the claims that achieve that. This is what you also need. So you need to have something. It can be centralized, which is maybe a bottleneck, but also it can be very sophisticated, decentralized oracle for market resolution. Then you have to have trading mechanisms, which are exactly the market venues, the marketplaces that we've introduced, that we talked about. And then finally, you need something that the user can interact with. So a front end, something that connects to those contracts and where positions can be created, positions can be stored, assets can be managed, and so on and so on. And if you implement this, you have a prediction market. So you have something where users can log on, then they can interact with the contracts, they can interact between their holdings, so they can actually trade assets on the protocol. There is something that tells the contracts what the outcome is and how to resolve this, and you have the asset representation. This is what you need. Those are the building blocks. And we've covered actually quite a bit of them. When you look at the smart contract, I'm going to just go through those slides very quickly. When you look at the smart contract layer, this is what you need to build: something to represent events, create markets, trade shares, resolve the market, distribute winnings, and manage the state. So those are actually the elements or the contracts of the protocol that you're going to build to handle all of those things. You can think about a more sophisticated middleware infrastructure. This is not required in the minimal implementation, but you can think about more sophisticated solutions, including wallet management, a transaction engine, backend services, everything that makes the system more efficient, more convenient for the user, more performant. And then on the front end, finally, cool features or cool ways for users to interact with, manage their holdings, and facilitate transactions. So those are the things that you would need. Okay, so now let's look at what I promised. So now let's look at the implementation of, at the comparison of the performance. So I want to bring your attention to this chart here. And if you have followed the conversation today very closely, you will immediately see what's happening here. So this is a price chart coming from one simulation model where the same question was answered by agents that were participating on two markets simultaneously, and one of them was a bonding curve market and one of them was an order book market. And what you see happening here is that for the market scoring rule, for the bonding curve market, you have very low volatility and you have continuous pricing, and you are within the band of, let's say, 45 to 43 to 48, something like that. So like very close to the so the midpoint of 50. If you look at the box plots, you see also very low volatility, and even for Monte Carlo runs of this experiment, you stay close within the range. So what does it tell you? It tells you that this market has continuous liquidity. There's very good price discovery. There are no major shifts. There is no big price jumps. Quite the contrary you see on the CDA side. We mentioned this, that here the price only moves when either a trade occurs or when you kind of like have an agreement between different orders placed in the order book, and you can say, okay, there is actually something happening that drives those prices. And those events are much more selective, and they are not that common. So you see that, for example, here, very long time, nothing happens with respect to the price. But obviously, signals are coming in. So people are placing different limit orders, but they're just not realized. Or they are not changing the mid price because kind of like those two orders are still pending. And then when potentially an order comes in that is clearing the market, you see a huge price jump immediately because you kind of like get this liquidity immediately swept out of the market. And performance-wise, what you see happening here is that, let's say at step 20, you have a very high discrepancy in prices between those two markets. And you now have the problem of the interpretation of probabilities that we started with initially, right? Because imagine that you have started, you have created a market that is an order book market. What would it mean? It would mean that the probability of the event happening is, let's say, I don't know, 25% on the order book. But if the same thing was traded on a continuous market, you would be around 50, which is kind of like twice the probability, right? So purely based on the choice of the market microstructure, you have a completely different aggregated metric. Nothing else changed. So agent beliefs are the same, agent signals are the same. It's just kind of how the market translates those signals into a pooled opinion or a pooled aggregate. This is completely different. So you immediately see how you can drive the market metric, the price or the probability, by the selection of the microstructure. So you have to be very careful what you do. And obviously, there are guidelines how you would do it, because we would imagine that those effects would become less extreme or less prominent if we had higher market volume. So if there is more activity on this market, on this order book market, it would probably converge to something similar than the continuous market. But we're not quite sure. And in the literature or the academic way to approach this, to answer this question is, there's a bunch of papers that is comparing market mechanisms, and you can do it in 3 different ways. So you can look at it from the ex ante, ex interim, and ex post perspective, which is nothing else than saying ex post. How well did the market perform overall? We look at metrics like price deviation, welfare, trader profit. So we look at something completely that is not the focus of our conversation today, because we have not put any attention on those questions right now. But they are quite important as well. So like you can perform this analysis. You can say, okay, how well did the market perform? We define those metrics, and then we see how it goes. But what is more interesting to us today are those ex ante and ex interim evaluations, where you would here, in this case, look at the mechanism, and you would try to evaluate which mechanism produced the most accurate forecast. So you would wait for the event to occur. You would see the market resolution. This is a requirement for this analysis, and then you would score the event outcome against the submitted forecasts, and you would be able to see, okay, how did the market perform that we've run on the order book side? How did the market perform that we've run on the market scoring rule side? And then we can compare which one was better, right? So like we can do an ex ante evaluation, but kind of like obviously after the fact, after we know how the market went, we can see which one was better. The more interesting approach, if we have not resolved it, so like during an ongoing market, is if we look at an ex-interim evaluation, and we would be asking the question of which mechanism incorporates information faster. So we would be looking at signals coming in, we would have both markets run in parallel, and then we would just look at them and see, okay, where does the information come in quicker? So like which market translates this information immediately into something that we can interpret as an effect on our market price. And the bottom line of all of those events, this research and those analytics is, and they are they quite agree on this bottom line, is that there is a threshold. So there is a particular number of trades or a particular depth of liquidity that you require, until which it is better to trade on a continuous market, a market scoring rule, and above this threshold or above this volume, you would be better off on the order book. And this is quite clear. So like there is a particular threshold, and the recommendation is before you set up a market, before you choose the market microstructure, what you do is you try to estimate how much trader activity you will have, how much interest in this market you will have, how is the information distribution across participants in the market, how many experts exist worldwide, how many people do you think would even participate. And if you feel like this is something that will draw a lot of attention and a lot of volume, then you can go with an order book. And then you are completely fine, because those markets are cheaper, more efficient, and quicker for high volume. If you feel like you will not get much attention and very difficult to get even kind of like first trader activity going on, then you should start with a continuous market. And in between, the proposal is to look into hybrid approaches. So you start with an automated market maker until you get a little bit traction, and then you transition to an order book. So this is maybe the answer why on Polymarket you can trade on events where basically everyone is an expert. So like everyone believes that they have a good opinion. So sports events, politics, where you have very high liquidity and very easy questions to answer, right? Like who will win, what will be the score, when will be the goal, whatever, where people just like are interested in participating because it's for fun, and it's and they don't have to think much about whether their opinion is valid or not. They just participate. And those markets operate, they work, but their business model is from generating fees. So they want to kind of like have this this interaction with users, and they want to earn money based off this activity. What I was trying to lead to today is that prediction markets are more than that. They are not purely betting systems. They are also information aggregation systems. And if you design them wisely or correctly, you can even use them in niche markets. So you can use them in a situation where only a handful of experts exist. For example, 5 or 10 people worldwide that would know something about an event. And you would very much like to get this information out from them, but on an order book market, like you would not get this price finding clearance, right? So you would get into the problem that we had on the simulation side, right? Like you would probably get into this here. And this is why, for such use cases, it is advised to create maybe a market that is continuous, that allows all participants to trade immediately and discover prices by active engagement. The downside of those continuous markets is that they require subsidy. So they need to be funded. So it's costly to operate an automated market maker. And there is, or a market scoring rule, better. And there is a lower bound on, an upper bound on losses that can incur. So you have to look at those systems quite differently. So you have to look at them through the lens of an information revelation system. You want to incentivize people to participate. You want the experts to share their opinion, and you have to pay them for revealing information. So you have to subsidize them. You have to give them something that they feel is worthwhile for them to capture by correcting the market state to a belief that is more accurate with their predictions. And that as the externality of the system, you actually create information. So you have created a market to discover prices, to discover probability. So this is kind of like the bottom line of the presentation, that prediction markets are more than simple betting systems, and based on the microstructure that you choose, the implementation that you choose, and so on, you are completely fine with defining those systems. What I did, and this will be the closing line, is, oops, yeah. So you see here, this is an experiment that I ran where you can't read it pretty well here, but what happens is that those are all different market microstructures, so different market scoring rules with different parameterizations and different functional forms. And you see immediately that when a signal comes in, they translate those prices completely differently. And this is maybe the nice thing to see, that depending on what you want to achieve, you can select from a menu of different market designs and then get the realization that supports or achieves your use case, that supports your use case that you want to look at. Perfect. So this is everything that I wanted to show you. This is the literature that I'm using. This is the publication in Nature, where you would be able to take one step back and look at the information aggregation in general and see whether prediction markets are even the right mechanism to choose. If you want to look into comparisons, those are the three ones that I recommend to you the most, because they compare between two market structures. One is ex post, one is ex ante, and one is ex interim. And then you have those two seminal publications, Hanson 2003, 2007, where he introduces information markets and market scoring rules. Very important piece of work. Perfect. Thank you so much for your attention. This is the end of the formal part of the talk or the workshop, but I'm happy to stay here for the next 10 minutes or so to get a more like conversation or interactive flow going. Thank you so much.